This is the first video on energy and momentum. This is on the conservation of energy. The second one will be on the conservation of momentum. In this video I'm going to talk a little bit about work and power, but mainly focus on kinetic and potential energies transferring back and forth. To start, work is what gives or takes energy away from an object or gives it to an object. So say for example you lift the block up off the floor and you put it on the countertop. You've given it energy. That energy came from you. This is why when the block, if pushed off the edge of the countertop, will begin to fall. It's gained potential energy because you put it on the counter. Another example could be a car goes ahead and burns gasoline, and in exchange it begins to accelerate. The car is doing work, giving the car itself kinetic energy as it burns the gasoline. Power is simply how quickly are you doing the work. So it's just work divided by time. Power is measured in watts, also known as joules per second. Kinetic energy is energy an object has because of its velocity. The faster an object's going, the more kinetic energy it has. Kinetic energy comes mostly from the velocity. Mass is important, but since the velocity term is squared, a lot of the energy is built up from the actual speed of the object. Potential energy is energy that an object possesses due to its location. There's multiple types of potential energy. There's gravitational, there's electrical, there's nuclear, there's spring potentials. So energy, potential energy, is often referred to as energy that's stored. For example, if I lift up an object and I just hold it up in the air, it has potential energy. That's why when I release it, it begins to accelerate and fall towards the earth and gain kinetic energy. The potential energy for gravity is mass times g, which is 9.81, times its height above the surface. Falling objects, say for example a ball that's just dropped, has potential energy, gravitational to be specific, and as it falls it gains speed. That gravitational potential energy is being converted into kinetic energy. Rising objects, say for example a ball that's rolled up a hill, on its way up it begins to slow down and eventually stops. The kinetic energy is being converted into potential energy. So let's take a look at some examples in a frictionless, airless world. Here we have a semicircle ramp with a ball that we release, and the ball begins to fall down the ramp. That potential energy is converted into kinetic, which then the ball can use that kinetic energy to roll back up the other side of the ramp. That kinetic energy has now been reconverted into potential. Since energy is conserved, it could not have gained more potential energy than it had to start with. So, since the kinetic energy ran out and it's all potential, the ball will begin to fall back down and rise up the other side. And without friction or air resistance, this process will happen until something comes along to stop it. This is due to the conservation of energy. Another example in the frictionless, airless world is a pendulum. So we have here a ball on a string hanging from the ceiling, and we release it and it will begin to fall. As it falls and reaches this middle point, it will begin to rise. But it cannot rise any higher than it initially started. When it gets to this height, it will fall back down and rise to its initial starting point. The potential energy here is being converted into kinetic, and then the kinetic energy is converted back into potential, which is then converted back into kinetic and back into potential. And without any friction or air resistance, this process, just like the ball on the ramp, will happen until something comes along to stop it. Thank you for watching.